Hey guys, it's Mr. Oda. In today's lesson, we're going to be going over topic 3.2, case-selected and R-selected species. In the last lesson, we went over what makes a generalist and what makes a specialist. This topic is going to be heavily related to the last one, so make sure you've watched that. Now, for our learning objective for this lesson, we're simply going to be identifying the difference between these two types of species. They are listed here in the essential knowledge, but we're going to go through the slides to get you a better idea of what this is talking about. So, for case-selected species, we got a couple of pictures here of bears, whales, kangaroos, and even humans. And that's because these kind of species tend to be pretty large. They also don't have that many offspring at a single time. As you know, for humans, we only have maybe 1, 2, sometimes 3 babies at once, but that's very rare. Same thing with bears, whales, and kangaroos. And this is mainly because we use a lot of energy to take care of each offspring. For example, in humans, we generally take care of our offspring for about 18 years in today's society. These organisms also mature after many years of parental care, but they also live very long lives compared to other animals and species that we'll talk about. One more important thing is that they can reproduce more than once in their lifetime. So humans can have babies multiple times in their life. Same thing with the other examples that I provided. And also, they live in generally stable environments. Now, the main thing that you need to take away from this one is that we use energy to take care of our offspring. The organisms that are case-selected generally have less offspring and put a lot of energy into taking care of them. And this is different from the R-selected species. And this is because R-selected species are generally small. They have many, many offspring at once. Some of these organisms, like flies, can have hundreds of offspring in the form of eggs at once. Tadpoles, the same thing. They use minimal energy for each offspring. So there are plenty of examples online that we're going to see of organisms that release a bunch of eggs or release a bunch of live offspring, but do not take care of them. They release them and then go about their lives. Another thing about these organisms is that they mature very early, but that also means that they have very short lifespans. Fruit flies generally last 3 to 5 days after they've reached maturity. They usually only reproduce once in their lifetime, and they're able to thrive in environments even if they've been disturbed. Now, let's take a look at these organisms. Are these species case-selected or R-selected? We have the giant panda and mosquitoes. Take a look at those organisms and tell me what you guys think. Hopefully, you figured out that the giant panda is a case-selected species, takes care of its offspring, only has 1 or 2, whereas the mosquito lays many, many eggs and does not take care of them, so they are R-selected. On a side note, this is not a black and white-ish topic. This is on a scale. So some organisms are more R, some organisms are more K. On the far side of the K, we have humans, chimpanzees, and primates like that. On the R side, we have oysters. They're making 500 million offspring every year. And somewhere in the middle, you have things like frogs and hare. They have more offspring than we do, but sometimes they also take care of them, and it's not as many as the oyster. One more thing to note with this topic is the idea of biotic potential. Biotic potential is the maximum reproductive rate of a population in ideal conditions. So, what that means is if there were enough resources to go around, if there was an unlimited supply of the things that the organism needed, the organism would grow in this way that's shown on the graph. This graph looks like an exponential growth. It continually goes up and up. Now, what I want you guys to think about for future topics in this unit is, in the real world, can this growth continue? Can their population, pretend this is cheetahs or zebra rabbits, can this population continue to grow infinitely, forever? Think about that as we go into the future topics. Finally, some key takeaways. Case-selected species, the ones like the bears, kangaroos, and us, tend to be specialists, and competition for resources in their habitats are very high, whereas our selected species tend to be generalists, and they don't have a lot of competition for resources in their habitats. There's just so many of them. Okay. For your final question, or questions for this topic, you're going to take a look at this graph on reproductive potential. We have the cane toad, dragonfly, rabbit, and elephant. Okay. For question 1, which species is most likely a K-selected species? For question 2, which organism can most likely become an invasive species? And for question 3, why are K-selected species more adversely affected by invasive species than our selected species? Make sure you explain your answers with evidence and reasoning. Hopefully you guys got those answers correct. Hopefully you guys understand a little bit more about what makes a K-selected species different from an R-selected. And if you have any questions, please reach out to me, and I will see you in the next video lesson. Take care, guys.